Hello students, now today we are going to discuss folding and time delaying are not commutative. Commutative means what? So if there is a discrete signal x of n is given, first of all we will fold. Fold means by time reversal of a discrete signal x of n is nothing but a folding of signal x of n. First of all you fold the signal by time reversal of a sequence x of n. After folding then time delaying. Time delaying means what? If you delay that signal, so first of all you will fold the signal x of n into x of minus n, then you will delay the signal means shifting, then whatever you get the sequence then are not commutative. Folding, delaying, then delaying, folding are not commutative, is not same. Okay. So in previous lecture already I told you what is delay or time shifting of a discrete signal x of n. In time shifting of a discrete signal x of n, if you will delayed means by k units of samples, that it is by if k units of sample it is delayed, it is nothing but x of n minus k. Here k is a positive integer, k is a positive integer. If you will delay the signal, if you are shifting by means of delay, we can say that in graphical representation the sequence shifted toward the right, but as far as sequence representation the arrow mark shifted to the left. This is nothing but is your time delay. In time advance, so here here k is a positive integer, in a time advance this is nothing but x of n minus k, and if it is a time advance it is nothing but what? Here k is a negative integer, it is nothing but x of n plus k, here k is a negative integer. We can say that it is a delay and it is not an advance, it is nothing but your advance of a discrete signal x of n, and this is nothing but a delay of a discrete signal x of n by k units of sample, where k is a positive integer, k greater than 0. If k less than 0, if k is negative, advance means the time shift result advance. If k, suppose if I will tell you a discrete signal x of n is given, suppose then by suppose if 2 units of samples, the delay is 2 units of samples, it is nothing but x of n minus 2. And here in case of graphical representation, each sequence, each samples shifted toward the right by 2 units, but in if you will represent x of n in sequence representation, the arrow mark shifted to the left. This is a fundamental concept of how you will shift the signal x of n. As far as in advance, if x of n is given by, if you will shift the sequence by means of advance means what? By suppose if it is 2 units of samples, here it is n plus 2, x of n is your discrete signal by means of n equal to minus 2, that's why x of n minus 2, and it is nothing but x of n plus 2. Here k is less than 0, that is your minus 2, here k is minus 2. That means what happened? A discrete signal x of n is given, and you can, the time shift results advance. Advance means if k is negative. K is negative means what? Here k is minus 2. So each samples of x of n can be shifted to the left by 2 units, and the arrow mark shifted toward the right by means of sequence representation. It is nothing but your delay and advance. Already I told you. Then how, if x of n is given, what is time reversal? Time reversal of discrete signal x of n. What is time reversal? In time reversal of discrete signal, time reversal, we can say what do you mean by time reversal? So time reversal of discrete signal x of n can be represented as x of minus n. So time reversal of discrete signal x of n can be expressed as x of what? Minus n. So we can say that it is a time reversal, or we can say folding, or we may say folding, folding of signal what? X of n. If x of n is your discrete signal, if you will fold it, suppose fd, I will say FD is your folding x of n, it is nothing but what? X of minus n. What do you observe? Folding of discrete signal x of n is nothing but x of minus n. Suppose if I will say x of n equal to, for example, x of n equal to, suppose this is your 2 and this is your 3 and 4 like this. This is your x of n. And x of n is represented as this one in a sequence representation. But what will be your x of minus n? What will be your x of minus n? In place of n, you put the minus 1. But whatever at n equal to this arrow mark indicate n equal to 0. This arrow mark indicate at n equal to 0. That will be constant. That is your what? This n equal to 0. This is constant. And left side of this arrow mark, this at every values, sample values here, that is n equal to minus 1. For n equal to minus 1, x of minus 1 is 2. For n equal to minus 2, x of minus 2, there is no 0. Similarly here, n equal to 0, n equal to 1, n equal to 1, x of 1, that is 3, n equal to 2, x of 2, that is your 4. Whatever at n equal to 1, it becomes n equal to minus 1. Whatever n equal to minus 1, it becomes n equal to 1. So swapping, whatever the value of n equal to 1, it becomes n equal to minus 1. That is n equal to 1 is equal to 3, and after folding, it will be n equal to minus 1. X of this one, n equal to 2, that is 4, and this is nothing but x of, this is nothing but your here, n equal to x of, whatever n equal to 2, it becomes n equal to minus 2 after folding here. Whatever n equal to minus 1, 2, it becomes n equal to 1, n equal to 1, this is nothing but 2. So this is nothing but your folding. Simply put n in place of minus n. You put n in place of minus n and minus n in place of n. So whatever the value of n equal to 0, that will be fixed. And 1, 2, 3 successively put minus 1, minus 2, minus 3 like this. Whatever n equal to minus 1, it becomes n equal to 1, 2, 3, etc. So this is all about nothing but folding. It is very, very important. Already I told you in your previous class what is shifting. Shifting means what? Either delay or advance. In a delay, in graphical representation, the each sample unit shifted toward the right. If it is 2 units of delay, by every sample unit is delayed by 2 units towards the right. But in sequence representation, the arrow mark will be shifted to the left by 2 units if the shifting or delay is 2 units. Similarly, in case of time advance, here in time advance, if x of n is your discrete signal, by time advance means x of n is your discrete signal. If it is k units of samples, if it is advanced by k units of samples, means what? X of n minus of minus k, x of n plus k, and k is negative. If k is minus 2, time shift result advance. So time shift result advance. In graphical representation, what happened? Each sample units shifted toward the left and the arrow mark shifted toward the right. It is all about your fundamental concept of if the discrete signal x of n is given, how will you shift the discrete signal by means of delay and advance and also folding. Folding means whatever the value of x of 0, that will be fixed, and 1, 2, 3 successively shifted to the minus 1, minus 2, minus 3, and minus 1, minus 2, minus 3 shifted toward the n equal to 1, 2, 3. So here the question is, if x of n is given, first of all, folding and time delaying are not commutative. Commutative means what? A into b equal to b into a as far as multiplication is concerned. As far as addition, a plus b equal to b plus a, that is your commutative. As far as commutative is concerned, folding and delaying. Folding means what? Already I told you what is folding. X of n, if you fold the signal x of n, it becomes x of minus n. So folding and delaying, if x of n is given, first of all you fold it, it becomes x of minus n. Then delay it. Delay means either maybe k greater than 0. Folding, delaying is not same as delaying and folding. What is second half? Delaying and folding. LHS left hand side, that is your folding and delaying. X of n is given, you fold it x of minus n, delayed by if k units of sample, x of minus n minus k, that is your folding and delaying. And delaying folding means what? X of n is given, delayed means by k units of sample, x of n minus k. In delaying then folding, in place of n you will put minus n. It is nothing but folding. As far as theoretical concept is theoretical things is concerned, so here folding and time delaying are not commutative. A b equal to b a as far as multiplication is commutative. Commutative law of addition, commutative law of multiplication. Similarly, folding, delaying, there are two terms, folding and delaying. What? The discrete signal x of n. Here the discrete signal x of n is given. First of all, folding and delaying, the time delay delay, time delay of k is x of n is nothing but x of n minus k. This is nothing but time delay. So x of n delayed by k unit of sample is nothing but what? X of n minus k. Our thing is folding of x of n. Already I told you folding means in place of n you will put minus n. So folding of x of n is nothing but x of minus n. The question is what? Delaying and folding. Time delay of folding. First of all, folding of x of n is what? Folding of x of n is nothing but x of minus n. So folding of x of n, this bracket, folding of x of n is nothing but x of minus n. The time delay of this one, time delay means where k is positive. So x of minus n means what? X of minus n. Folding of this, the time delay of x of minus n is nothing but x of minus n plus k. It is nothing but time delaying and folding. One thing is we should keep in your mind, as far as simply x of n is given, if you folding, it is nothing but x of minus n. If it is your delay means k is positive, x of minus n, delay of this means what? That is your x of minus n plus k. Same thing, if x of n is given, then first of all your delay means what? X of n minus k. Remember, delay means x of n minus k. If you fold, in place of n you will put the minus n. So x of minus n minus k. And this is not equal to same. So that is your delaying folding is not same as folding and delaying. This is your delaying and this is your folding. So delaying and folding is not same as folding and delaying. Your original signal x of n is given. First you delay by k units of sample means k is positive, x of n minus k. You will fold it. Fold it means in place of n you will put minus n. It becomes x of n minus n minus k. If it is folding, x of n folding means minus n. Folding then delaying. When the signal already fold, that means x of minus n. In folding x of minus n delay, it is nothing but minus n plus k, not minus n minus k. Remember. So this is not equal to this. As far as so we can say that folding and delaying are not commutative. So if first folding then delaying is not same as delaying and folding. It is most important. So here same thing. So folding, delaying are not commutative. So x of minus n plus k is nothing but what? Folding then delaying. And here that is your delaying then folding is nothing but x of minus n minus k. So this is not equal to this, as far as folding and delaying are not commutative. If we will give an example, suppose if we will give an example whether shifting or folding shifting are commutative or not, means fast shifting then folding or fast folding then shifting of a discrete signal x of n is same or not. If this fast shifting then folding is not same as, if this equal this, whether this folding, shifting and folding is same as folding and shifting. And suppose x of n is given, suppose a discrete signal x of n here given, x of n, suppose I can say that is your 1, 2, that is your 1, 3, and this is your let 2 here. X of n is given, we have to check whether the x of n shifting folding and folding shifting are commutative or not. What we will do? Solution. Here x of n is given what? This is your x of n. As far as graphical representation is concerned, this is your 0, this is 1, and let this is your 2. First of all you will mark it in 0, that is 1, 0 that is 1, and 1 that is what? 3. 1, let this is 3, this is 1, and this is 3, and then this is 2, into at 2 n equal to, that is your 2, and minus 1 that is 2, minus 1 that is 2, and minus 2 that is 1, minus 2 that is 1. This is your original discrete signal, that is your x of n. Then what we will do? First shifting. Suppose n equal to positive, y n equal to 1. Suppose if I will say n equal to 1, n equal to 1 means what? If n equal to 1, suppose k equal to 1, if k equal to 1, suppose k equal to 1 means what? X of n minus 1. X of 1 means delay. If it is delay means what? In graphical representation, each units of samples, each sample unit can be shifted to right by 1 unit. So it becomes what? This is let 0, 2, 3, and if you have to mark here like this. Whatever 0, that becomes what? 1, whatever 1, that becomes 2, whatever 2, that is 3, and whatever minus 2, that becomes minus 1. So whole sequence shifted by towards right by 1 unit. So that's why this is your 1 and this is your 2, this is 1, this is your let 3, and this is your 2. This is nothing but what? X of n minus 1. This is nothing but x of n minus 1. We can say this is your x of n minus 1. Okay. So first of all, shifting, then folding. If you fold it, folding means what? If you fold it means what? In place of n, then it will be minus n. That becomes what? X of, we can say x of, in place of n, that is your minus n. X of minus n minus 1. So if this one, what will be your sequence? Like this. So in sequence representation, x of n minus 1 is how much? In x of n minus 1. So that is your okay. So already I told you, if x of n is given, if it is shifting means delaying, in graphically the sequence each unit of sample shifted towards right, since it is k is 1 means 1 unit, and in your arrow mark shifted to the left. Here arrow mark originally x of n was here, arrow mark shifted to the left means by 1 unit, since n is equal to 1, that's why like this. This is nothing but what? X of n minus 1. This is nothing but what? X of n minus 1. So after shifting, first shifting, then folding. Folding means what? Swapping whatever n equal to 0 as same as it is, that is your what? In 0, like this, 0, in 0, same 2, whatever minus 1, it becomes plus 1, this is 1 also, this is minus 1, this is minus 2, minus 3, like this, whatever 1, same as this one, this is your 1, then 3, then 2. This is nothing but folding here. This is nothing but what? X of minus n minus 1. First of all, original sequence is your x of n, then shifting by means of delay, then folding in place of n, that is your minus n. Whatever n equal to 0, same as it is. Whatever n equal to 0, that is 2, is same as it is. Whatever 1, 2, 3, that becomes minus 1, minus 2, minus 3. Whatever minus 1, minus 2, minus 3, it becomes plus 1, 2, 3, like this. Here only in negative, minus 1, only one samples here, that is 1. So that's why in plus 1, that is only 1 here. Okay. So this is your shifting, then folding. If you reverse means what? X of n is given, first of all you will fold it. If x of n is given, then folding, first folding. Folding means what? Whatever n equal to 0, as it is, n equal to 0, that is 1 here, like this, 1. Whatever minus 1, it becomes plus 1. This is your 1, this is your 2. Similarly here, this is your minus 1 and this is your minus 2. So whatever minus 1, as same as plus 1, that is 2. Then minus 2, 1, that is becomes plus 2, this is 1. whatever 1 is equal to 3, they become minus 1. This is your 3, and 2 becomes minus 2, that is your 2. So this is x of what? Minus n. After folding, this is your x of minus n. Then what will do? X of minus n. X of minus n in as far as sequence representation, x of minus n is nothing but what? X of minus n in sequence representation, x of minus n equal to, that is your whatever n equal to 0 as it is like this. So this is your 3, this is your 2, and similarly this is 2 and this is 1. This is your x of minus n. This is your x of minus n. It is nothing but folding. After folding, then shifting. After folding, then what? Then shifting. Shifting means what? In originally, first of all, here k value here what? 1 unit of sample is shifted here. Means k equal to 1. If it is shifted means what? X of minus n. X of what? It is a delay. In after folding, this is nothing but x of minus n plus 1. Minus n plus 1. In minus n, x of minus n plus 1, what happened here? Each graphical shifting means here delay. Each sample shifted toward the right by 2 units. So that's why whatever here minus 2 becomes minus 1, whatever minus 1 becomes 0, like this. So x of minus n plus 1, the sequence is like this. This is your 0. Okay. So here that is your minus 2, that is your 2. Okay. So this is nothing but x of minus n plus 1. If x of minus n this, in graphically each unit of sample shifted toward the right, so it is nothing but delay. As far as in sequence representation, this is x of minus n, and x of minus n plus 1 is how much here? X of minus n is plus 1 is like this. That is your n equal to 0, that is 1, and that is your here. Okay. So here is x of minus n in folding, then shifting. Each unit of sample shifted toward the right by means of graphical representation. In sequence representation, the arrow mark shifted to the left by 1 unit. Since x of minus n plus 1, the arrow mark shifted to the here, it is nothing but x of minus n plus 1. Here folding, shifting, the sequence is like this. Then shifting, folding, the sequence is like this. So this is not same as this. So this is not same as this. So this is not same as this. So folding, shifting, folding is not same as folding, shifting. So thank you. We will do more and more number of examples in the next lecture. So we will discuss more and more number of different types of problems, so that you will be more clear about the your fundamentals. So thank you.